45. In decimal, in binary it would be 32, 16, so 8, 40, 44. So this is in binary. Now take another number, let's say 64. It is easy. Okay, so 64, 32, 16, 8, 4, 2, 1, 1, 2, 4, 8, 16, 32, 64. Now take one binary number 1, 1, 0, 0, 1, 0. So in decimal it would be 1, 2, 4, 8, 16, 32. It would be 50. If you want to know how I am converting this without dividing the number, then watch this video further. Let me first tell you how we convert any decimal number into binary. First we have to know the basic behind that. So just say 49. So to convert any decimal number into binary, we divide that number with the base. The base of binary is 2, so we will divide this number with 2. So this would be 24, the remainder is 1, again 12, the remainder is 0, again 2 into 6, 12, remainder is 0, then 2 into 3 is 6, remainder is 0, then 2 into 1 is 2, remainder is 1. So now we got 1, so you have to write this number in reverse order. So what it would be? 1, 1, 0, 0, 0, 1. So this is equivalent to binary number. Let me write some numbers. It's 1, 2, 4, 8, 16, 32, 64, 128, then 256, 512, 1024, 2048, 4096, 8192. I remember only this. One thing which I have observed is that, let's see any number 3, 4 and 5. So the value of 5 is 5, the value of 4 is 40 here, and the value of 3 is 300 here. So what is happening here is that here the value is 5, and when we are going for the next digit, it is being multiplied by 10. So the actual value is 4 into 10. So again in 3 it is multiplied by 100. Now if you go for the next digit, let's say 4, the value it would be 1000. So why it is happening like this? Because see, this was 1, now it's 10, 100. It is being multiplied by 10 because we are using the decimal number system. This is most important point you have to keep in mind. Let's take binary number 0, 1, 0, 0, 1. The same way, if we are taking any binary number, so it will start with 1 and we will multiply the same number with the base, and the base of binary is 2, so 1 into 2 is 2, and if we will multiply 2 with again with the base, it would be 4, then 8, 16. So how it is being increased? And whenever we see 0, that won't be counted because 0 into 1 would be 0, and but if there is a 1, so that would be multiplied and that will give a number. Like the same way, where we are multiplying 1 into 5, 5, here 4 into 10 is 40, 3 into 100 is 300, 4 into 1000, 4000. So like this you can increase this one 32, 64. So if you remember this one, this method and this number, then you can convert any number very easily, either from decimal to binary or binary to decimal. Now let me take some example in which I will tell you how you can convert any number from decimal to binary and binary to decimal very easily and fast. Now let's take one example which says 70. So what you have to do is first choose the number, any one from this one, which is nearest to this one but lower than this one. Okay, you have to choose any number between this list which is nearest to the 70 but not greater than this. So what is that? 64. Okay, so you have to turn that bit on. Okay, so I have written here 1. So now it will be counted, and consider this in your mind that okay, I have selected 64. Now if you have taken the 64, now go backward. So if you will go backward, so the next bit will be 32. So do you want to add that 32 in this? Of course no, because that would be 96, and the required result we need is 70. So we will turn that bit off. I mean the 32 will not be counted. Now the next bit is 16. Do you want to add that? No, we also don't want to add that as well. So again we will put this 0. Now the next one is 8. If we will add the 8 to 64, that would become 72, but we require 70. So again we will put 0. Okay, next is 4. So do we have to add that? Yes. So we will add, and to add that number we will put 1. So 64 plus 4, it would be 68. Now next bit is 2. Do you want to add? Yes. So again I have put 1. So it would be 64 plus 4 plus 2. We got the required result, but the next bit is also 1. So we have to put 0. So this is how you can easily calculate any number, I mean at least till the 1000. Beyond that it might be difficult even for me as well. Below 1000 or 2000 it can be done easily. Let's take another number, 150. And what is the nearest number to 150? So 150 is 128. So we will take 128. Now do we have to add 64? No. So I'll put 0. 32, yes, we have to add, and we got the required result 150. Now how many bits are remaining? 3 to 5. So put the 50. 1, 2, 3, 4, 5. So you can easily convert any decimal number into binary. Now let's take another number which says 796. Okay, so nearest number is 512. Okay, so I have taken 1. Now if we will add 512 plus 256, how much it will be? 768. Okay, 6 to 8, yeah, 768. So we also have to add that. So we got 768. We have taken this one as well. Now do we have to add this 128? No. So it would be 0. 64? No. Then 768, 32? No. Now we got 768, 32. Now add 16. So if we will add 16, 8 in 6, 14, 1, 1, 2, then 8, 784. So we have to add 16, then 8, add it. So we will get 792. So add it, and then 4, add it as well. So 4, we got the 796, and now 2 bits are remaining, 1, 2 and 1. We will put that as a 0, and now it has been converted. Let's take another example, 317. So the nearest number is 256. So here 1, then 128. Do we have to add that? No. So it would be 0. Do we have to 64? So let's just check it. 256 plus 64, it would be 6, 4, 10, 1, 6, 6, 12, 320. So no, we will also not add 64 as well. Okay, now what about 32? Just add 256 plus 32, it would be 8, 538, 288. Yes, we will add. So we have added that. Then what about 16? So add 16. So 8 plus 6, 4, 8, 9, 304. We will add that. Now 8. Do we have to add that? Because we got the required result is 304. Yes, we have to add that. So now it become 312. And now do we have to add that 4? Yes. So it will become 316. Do we have to add 2? No, it would become 318. And now do we have to add 1? So yes. So it will become 317. Now you have a clear idea how you can easily convert any decimal number into binary. So I was talking about this lengthy number 300, 500, 600, and if someone says just convert this 65, this is so easy. Just 64, 32, 16, 8, 4, 2, 1. That's it. Now just take another example. If someone says 21, so you have to use 16, 8, 4, 2, 1. This is in binary. Let's take another example, 30. Okay, so 30, 16, 8, 24, 28, 30. This is, just say 40. So it would be 32, 16, 8, 44, 45. Okay, I have converted by mistakenly 45. Okay, 1, 2, 4, 8. Yes, now I was talking about 40, so it would be 30, 32, then 16, 8, 4, 2, 1. So this is how easy it is. Now I will take some example in which I will tell you how to convert from binary to decimal in the same way. Now let's take the binary number and we will find the decimal equivalent to that number. So the first one is 1000,110. So what you have to do, as I told you, the weightage is 1, 2, 4, 8, 16, 32. If you can do in your mind, that's also well and good. If you cannot, so just put it here as 1, 2, 4, 8, 16, 32 and 64. So how much it would be? Just add only those numbers where 1 is present, not 0. So now you can see for 4, 2 and 64 it is on bit, so you have to add only this one. 64 plus 4 plus 2, it is 70. Okay, now let's take this one, 1 0 1 0 0 0 0 0. So again you have to do the same thing, 1 2 4 8 16 32 64 128. 128 plus 32, 150 plus, okay, that's it. So it is 150. We got this one. Now this is the way you have to do. Now just take another example. I am taking this one. Which one? This one. 1 1 0 0 0 1 1 1 0 0. So either you, if you want to do in your mind, so just do 1 2 4 8 12 16 28. So just put it 28 and it was 16. Okay, 32 64 128. Okay, 256 and 512. So you have to add 256 and 512. Add it here, it is 28. So 8 2 10 plus 6 16, then 2 7 9 and 796. Yeah, that's fine. Now take this one, 1 1 1 1 0. If the number is below 1000, then you can do it just few seconds. So just take this one, 1 2 4 8 16. Okay, so 2 4 8 16 you have to add 2 4 6 plus 8 14 plus 16 is 30. That's it. Now just take this one, 1 0 1 0 0 0 1 0 0. Okay, now you have to do how? 1 2 4 8. Okay, 8 16 32. 8 plus 32 is 40. I got it. Okay, now let's take another example, 1 1 0 0 1 0 1. So what you have to do is just in your mind, just think 1. Okay, 2. No, I won't add 4. 1 plus 4 5. Okay, 8 16 32 plus 64. Okay, so I got 5 plus 32, 37 plus 64. So 37 plus 64, 1 and 6 3 9 101. So it would be equivalent to 101. Now take 1 1 0 0 1. So 1 2 4 1 2 4 8 16. So it would be 25. I hope it's clear now, and if you follow the same way, you can convert any binary number in just few seconds. And as I told you in my previous video, if you know the conversion between decimal to binary, then you don't have to remember anything, any rule. You can easily convert any number from any other number system to different number system. I hope it's as easy as it looks. Okay.